morning, afternoon, or evening. How y'all doing? Welcome back to Morrow's Math Corner. Today, guys, we are going to be working on Radicals Lesson 2. I know you guys are really excited because the end of school is near. All right, guys, well, let's finish strong, okay? So let's talk about radicals. We've been talking about radicals a lot. We know already how to simplify them. We know how to rationalize them. We know the difference between even root and an odd root. Let's talk about now today adding, subtracting, multiplying, dividing them, and solving them. Model, that's a lot. I know, but we're going to destroy it. We're going to modify it, and we're going to just learn like we've never learned before. So, guys, what is a like radical? A like radical is kind of like a like term. If you remember, like terms, they were the same variable raised to the same power. Well, in this case, guys, like radicals are radical expressions that have the same exact index. Little friendly reminder, guys, remember the index is that number there. Okay, brothers? Same index and radicand. And only like radicals can be added or subtracted. So let's think about that. Remember we talked about multiplying already. We're going to review it today again. But multiplying, all you need is the same index. But when you're adding them, my friends, they must have the same index and the same radicand for them to be like radicals. So here, guys, look at it this way. This is 3 square roots of 5x's minus 2 square roots of 5x's. So what would that be, guys? Yeah, don't be afraid. Yeah, it's just 1. You have 3 square roots of 5x's minus 2 square roots of 5x's. What am I left with? 1 square root of 5x. Done. Done. Bye-bye. For number 2, we got a little bit of an issue here. First of all, is 6x squared and 4x, are those like terms? No. Secondly, let's say they were. Is square root of 7 and square root of 5, are those like radicals? No, because they're not the same radicand. Remember that like radicals, my brothers, have the same index and the same radicand. So in this case, there is a no because you have the square root of 7 and the square root of 5. Okay, here for C, are these like radicals? No. No, they have a different index. However, you know that Moto likes to throw little curveballs at you all the time. They do have the same base though, don't they? So technically speaking, oh, actually no, because no, you're not multiplying these. So no, you can't add these. No, you're good. All right, next, D. Okay, I got 17 fifth roots of 3x squared minus 15 fifth roots of 3x squared. So what am I going to be left with, y'all? 2. Very well stated. Very well stated, gentlemen. Very well stated, gentlemen. Proud of you. Last but not least, my brothers and sisters out there watching, can I add these two together? Yes, they are like radicals. So what's 5 cube roots of x plus 3? Let's go. Woo! Good job. Let's go, baby. Bam. That is papita, right? All right, now you get to the real life, okay? Now you get to what a teacher would ask. Now you get to what an SAT would ask, an ACT. Now you get to the real life, guys. Moto, none of these are like radicals, bro. We're just going to move on, right? No. We got to always first simplify the radical, which we know how to do, before we can determine if they're like radicals or not, my brothers. So this here breaks down into, or I would say instead of 6 and 2, 3 and 4. What's the square root of 4? So this is 2 square root of 3 plus, me personally, I break that up into 3 and 25. What's the square root of 25? 5 square root of 3. See the beauty of knowing your perfect squares? And then you have a minus square root of 3. Now that we've simplified it, my friends, Now, can we change our tune? Can we add these now? Yeah. So what would 2 square roots of 3 plus 5 square roots of 3 minus 1 square root of 3 be? 6 square roots of 3. Excellent. Excellent job. Excellent job. Okay, guys, let's try to work this together, huh? Cube root of 250. What do you think is the best way to start breaking down this 250 would be? It's even, hint, hint. I'd go 2 and 125. I always like to go with 2 because it really makes life a lot easier. And guys, does anyone know? Have you learned the pattern yet? What's the cube root of 125? Let's go. So that's 5 cube root of 2. Great job, brother. Great job. Okay, 54. What's the easiest way to break this down? Hint, hint, it's even. Let's go, brother. Let's go. What's the cube root of 27? Let's go. And I have a cube root of 2 left over. My friends, how can I break down 16? What's the easiest way? Hint, hint, it's even. 2 and 8. My brothers, what's the cube root of 8? Let's go. So you got a 2 with a cube root of 2 left over. Do you see the magic that I just dealt out there? That's minus. Thanks, Papa. Appreciate you, dog. All right. So what's 5 cube roots of 2 plus 3 cube roots of 2? Well, 8 cube roots of 2 minus 2. Boom. Woo! There it is, baby. Well done. Excellent. Excellent. All right. We're ripping this up, right, guys? You got this? All right. Let's break this bad boy down. 14. What does 20 break down to? 2 and 10. Now, in this case, 2 and 10. And then the 10? So every pair comes out. So a 2 and a 2 comes out as a... And what do I got left over? Excellent job, guys. So that's 28 square root of 5. Minus. What does 125 break down into, my brothers and sisters? Let's go. 5 and 25. What's square root of 25? Woo! Hit it. What you got? No, it's not 3, Papa. 23 square root of 5. Let's go. Let's go. How can I break down 32 the easiest way? 2 and 16. What's the 4th root of 16? 2. So I got a 2 with a 4th root of 2 left over. What's the easiest way to break down? 48. 2 and 24. I don't have anything yet. 2 and 12. Nothing yet. 2 and 6. Nothing yet. Ah, there it is. 2 and 3. So I got 1, 2, 3, 4 2s. Comes out as a... And what do I have left over? Oh, wait a second. Can I add those? No. But guess what? I simplified it, and that's spectacular. That would be my answer. I cannot go any further. I cannot go any further. Does that make sense, y'all? All right. I like it. May I continue? Let's go. What on earth are you doing to us mortal? I'm taking old skills, bringing them together with new skills. Don't be afraid. Yes, sir, my brother. My man, my man. Woo! Good job, brother. Of course you distribute. Square root of 6 times 3 is 3. Square root of 6 mortal. Don't you multiply them? You cannot multiply a whole number with the inside part of a radical. So you multiply it to the radical's coefficient, which in this case is an invisible 1. Square root of 6, though, times negative 5 square root of 6. This is, what's 6 times 6, guys? What's the square root of 36, guys? Okay, so I got a little trick for you. You ready? The square root of x times the square root of itself, x, will always equal x. Wait a second, Motor. What do you mean? Square root of 2 times square root of 2 will be 2. Think about it. Square root of 2 times square root of 2 is a square root of 4, which is 2. Square root of 7 times square root of 7 is 7. Square root of 5x times square root of 5x is 5x. Square root of 1 billion times square root of 1 billion is 1 billion. The square root of a number times its exact self is always equal to the radicand. So I don't go through that big mess that I just went through with you. 6 times 6 is 36. The square root of 36 is 6. No. I say, oh, square root of 6 and square root of 6, it's 6. Done. So now I have 3 square root of 6 minus 30. You guys picking up what I'm putting down here? Okay. Now, we distributed there, guys. What's it called when we multiply a polynomial times a polynomial? FOIL. Thank you. Let's go. 3 times 5. Woo! Plus, let's go, brother. Proud of you. Excuse me. Let's go. Minus 7. Excellent job. Way to catch on, brother. 15 minus 7 is 8, guys. Minus 2 square roots of 7. Let's go. Questions? Talk to me. I know I'm going fast, but I know you can handle it as well. Yes, sir, my brother. Thank you.
The 15 and the 7 are like separated?
Yeah, they're separate constants, and they're constants, so you can add them together. You got a 15 over there, and then you have a negative 7 over here. You can add those two for sure. Thank you. Sir? If the index here was different, when you multiplied them, you'd have to convert it to a fraction and add the exponents there. Because you can multiply the insides as long as the indexes are the same. If the indexes are not the same, but they have the same radicands, you can raise those radicands to the fractional exponents, add the fractions, and then rewrite it as a radical. Yes, no, maybe kind of, sort of. Okay. Right here. 3 times 2. 3 times 4 square root of 5. 2 square root of 5 times 2. 2 square root of 5 times 4 square root of 5. Beautiful. 2 times 4 is 8, but square root of 5 times square root of 5 is 5. 8 times 5 is 40. Wow, that was spectacular. 40 and 6 is 46, so this is 16. Square root of 5 plus 46. Does that make sense? Promise, guys? Okay, and then what is 2 square root of 5 plus 3 square root of 2 squared mean? Thank you. This is 2 square root of 5 plus 3 square root of 2 times 2 square root of 5 plus 3 square root of 2. All right, what's 2 square roots of 5 times 2 square roots of 5? No, it's not 4 square root of 5. It's 4 times 5, right? Because what's the square root of 5 to the square root of 5? So times 4, that's 20. Then 2 square roots of 5 times 3 square roots of 2. You're on it. 6 square roots of 10. Remember, when you can multiply the same base if the indexes are the same. 3 square roots of 2 times 2 square roots of 5. Excellent. And 3 square roots of 2 times 3 square roots of 2. Take your time. What's 3 times 3? No. 9. And what's square root of 2 times square root of 2? 2. So what's 9 times 2? 18. Baba, square root of 2 times square root of 2 is square root of 4, which equals 2. But remember, we just learned this. Square root of 2 times square root of 2 will equal 2. Make your life easy. Why, Moro? Because square root of 2 times square root of 2 is 4. What's the square root of 4? 2. It will always work that way. The square root, guys, the square root of anything times the square root of itself will equal the radicand always, 100% always. It's a good trick to know, my brothers. And then here we add like terms. Bam, I couldn't have said it better myself. Let's go. Is that making sense here, guys? You're just awesome. May I? Let's go. When a radical appears in the denominator. Hey, we talked about this yesterday. you must convert the quotient so that the denominator does not contain any radicals. This process is called rationalizing the denominator. And the SAT, they'll say, rationalize the following expression. If you don't know what rationalize means, you're going to be in a world of hurt. So in order to rationalize, guys, okay, a denominator containing a single square root, simply multiply the numerator and denominator by the square root given. And then remember what I just finished talking about. Square root of a times square root of a is a. The square root of something times the square root of itself will always equal the radicand, the inside part. And that's going to help you big time, and I'm going to show you how. Guys, I have a square root of 1/5. How many 5 do I need in total to take out 1/5 from a square root? No. No. Okay. Square roots. What am I looking for, guys? How many of one value do I need to pull one out? Okay. So I would need 2 5s to pull out a 5, correct? How many do I have? How many more do I need? So multiply square root of 5 to both top and bottom. So I got 2 square root of 5 over 5, and I'm done. How did you get 5 in the bottom? Didn't we just review that square root of 5 times itself is going to be the radicand? Done. Done. My brothers, how many 12s do I have in a square root there? How many do I need to pull one out? No, how many do I need in total? How many more do I need to there you go. So that's going to be the square root of 84 over 12. Now let's break down the square root of 84. What would that break down into? Huh? 2 and 42. 2 and 21. 3 and 7. Okay, so every pair comes out as, so a 2 and a 2 comes out as a 2 with the square root of 21 over, reduce it. Yeah? There you go, my brother. Square root of 21 over 6. Let's go. Let's go. Let's go. Very proud of you. Guys, for C, I have a 5. That's not in a square root, so I don't have to rationalize that. But I do have the square root of 2x. How many more 2x's do I need to pull out 1 from a square root? You need 1 more. So I'm going to literally multiply square root of 2x to both top and bottom. What am I going to get in the numerator? 4 square root of 2x. Good man. And then, take your time. You have your 5 times. What's the square root of 2x times the square root of 2x? There it is, 2x. So now I can reduce, though. So my answer will be 2 square root of 2x over 5x. Have a good day. Excuse me. It's not that bad, right? It's a lot. I know it is. I know it is. You guys are bosses. But it's not that bad. We're almost done, okay? We're almost done. Yeah? What up? What? You cannot multiply the 2x and 5 because you have a whole number and that one's in a radical. Thank you for asking. You can't. Yes? Move forward? All right, let's do this. All right, guys. So now, rationalizing the denominator, okay, which contains an nth root radical, works the same way. Okay, same way. The goal is to multiply both the numerator and denominator by the nth root that creates a perfect power of the nth root. So the denominator does not contain a radical. Tip: if you know your perfect squares, your perfect cubes, fourths, it's easy to create powers of the given nth root. For example, if we had to rationalize the quotient which contained the cube root of 4, okay, you would multiply the numerator by the cube root of 2 in order to get the cube root of 8, which would equal a 2. So let me explain what that means in normal terms. Okay, I got a cube root of 6. How many 6's do I need in total to pull one out? 3. How many more do I need? That's it, guys. That's all it is. Now watch. Watch the magic. So I have the cube root of 36 over. Pay attention. This is the cube root of 6 times the cube root of 6 squared. Wouldn't that be the cube root of 6 cubed? Which is 6. Done. So you do have to ask yourself, how many more do I need? How many more do I need? How many more do I need? Okay? And guys, I would love to do more of this with you, but I find myself running out of time. Okay? I'm going to do one more, but I'm not going to do C. I am going to do B, but I'm not going to do C. For 3, first of all, you break this, for B, you break this up, and then you cube root of 18. But instead of writing 18, guys, to make my life easier, I'm going to break that down into 2 times 9, which is 2 times 3 times 3. Now you may say, why did you do that, crazy modal? Crazy modal did that because of this. Guys, how many more 2's do I need at this point? No. And how many more 3's? Done. Makes life a lot easier. So that's 12. So I have now the cube root of 60 over 2 times 2 squared is 2 cubed. The cubed root of that is 2. 3 squared times 3 is 3 cubed. The cubed root of that is 3. So 2 times 3 is 6. And you're done. And you're done. I got 10 minutes to make magic happen here. 10 minutes. So breaking down those numbers into its factors really helps you understand, because here I needed 3 of the same. Well, I had 1, 2, so I need 2 more. Since I broke that down into my 2 3's, I only needed 1 more 3. It makes it a lot easier than doing this, multiplying the cube root of 18 squared. You could do that as well, by the way. You could have done that. You just got a lot more math to do there. But it is a personal choice that you have. Okay? All right. Guys, we're actually going to... No, I got to show you this. I got to. I can't skip out on this. Okay. Conjugates, guys, are expressions that have an addition or a subtraction of radicals. Square root A plus square root B, or square root A minus square root B. Okay, conjugates is when you have an opposite operation. The square root of A plus square root of B, the conjugate of that is the square root of A minus the square root of B. Okay? The conjugate of 1 minus square root of 5 is 1 plus square root of 5. The conjugate of 3, square root of 3 plus square root of 2 is square root of 3 minus square root of 2. To find the conjugate of a radical sum, you simply change the sign in the middle. Now, why is that useful? Well, guys, sometimes you have to rationalize the denominator. So that means you're going to have to multiply the numerator and the denominator by the conjugate. But I've got a little hint here. Let's see what happens when you multiply by a conjugate. If you guys remember, difference of squares, when you multiply by a conjugate, guys, it's the first term squared minus the second term squared. So when I multiply 5 minus square root of 7 times 5 plus square root of 7, sure, I could do it the long way. 5 times 5 is 25, plus 5 square root of 7, minus 5 square root of 7, minus 7. 25 minus 7 is going to be 18. 5 square root of 7 and the minus 5 square root of 7 cancel, and I'm done. You could do that. There's not anything wrong with that. Or you could remember a little bit more high-level math that we've learned. Remember that this is a difference of squares. So first term squared minus second term squared. That'd be 25 minus 7, which is 18. Done. If I had to multiply the conjugate of 6 minus square root of 12 times its conjugate, well, that's a difference of squares. They're both identical except one's being added, one's being subtracted. So the first term squared is 36 minus the second term squared, that's going to be 12. So 36 minus 12 would equal 24. Correct. Correct, my brother. These guys cancel. So how do I use it? Whenever you have a radical in the denominator, guys, if it's being added, you got to get rid of it. You got to. I'm just going to do one of them. So I'll do, I don't know, I'll do A. All right, I'm going to multiply by the conjugate. That's how I get rid of this denominator. So I'm going to multiply by square root of 5 plus square root of 2, square root of 5 plus square root of 2. Distribute. That's going to be 3 square roots of 10 plus 3 times 2 is 6. Now, first term squared, 5, minus second term squared, 2. There's going to be 3 square root of 10 plus 6 over 3. The 3 divides to here and to here. A skill we've learned before. Square root of 10 plus 2. That is how you conjugate when you have a sum in the denominator. That is how you conjugate when you have a sum in the denominator. Okay? All right, we're at the end. We're at the end, guys. I'm going to make it. I'm going to make it. Okay? Last thing. And this is actually quite easy. Radical equations. Hopefully, some of you will say, wait a second, Moro. So sometimes you'll say, you may say to yourself, hey guys, hold on. Give me 1 second. All right, guys. So when you have a radical equation, guys, remember when we worked with quadratics? We've worked with equations with radicals already. And if you remember, how do I get rid of a square root? By raising it to a power of 2. Very good. And I get rid of a cube root by raising it to a power of 3. And I get rid of a fourth root by raising it to a power of 4. Very good. Whenever I raise an index, a radical, to the same index, I cancel out the radicals. So guys, first things first, isolate the radical. Get it by itself. Second, cancel out or eliminate the radical by raising both sides of the equation to the power of the index. And then solve the equation and check for extraneous solutions. Remember, extraneous solutions, guys, are those answers that you got but don't work. So now, let's get to this, guys. We're almost done. I want to get the radical alone. So I'm going to add 5 to both sides. Guys, how do I get rid of that radical? Square both sides, my brothers and sisters. So now I have 4x plus 1 equals 25. Subtract 1. 4x equals 24. By 4, that's my boys. X equals 6. Woo! Let's go. That's it. Like, literally. That's it. Number 3, or B, subtract 3. I got the square root of 2x minus 3 equals 5. How do I cancel that square root, brothers? Bye-bye. 2x minus 3 equals 25. Hit it. Uh-huh. And then? Yes, you divide 2. And then? Come on, man. Come on, man. Check this one out. Look at D real quick. Real quick, because I'm running out of time. When I subtract 7, I got the square root of 5x minus 1 equals a negative 2. Uh-oh. I can't have a square root equal a negative. So that's going to be a big fat no solution. Very good. Guys, if I tell you that this is a half, what is that really? A square root, so don't be afraid. That'd be 5x minus 1, subtract the 3, equals 7. Square both sides, y'all. 5x minus 1 equals 49. Add the 1. 5x equals 50. Divide by 5. Oh my God, guys, it has been an honor to teach you. We are done. We have closed out the year. Thank you. I hope you guys learned a lot. I hope all of you at home learned a lot. Many blessings to you and yours, and I am out. Moro's gone. Bye-bye.